typically, or the steps before said move your constant. But here's the thing, I want the constant isolated on one side and the quadratic and the linear term on the other side. So this is an example where I'm actually going to move that linear term to the other side. So this is where I move the linear term to the other side by subtraction, and I get x squared minus 4x equals negative 13. We're going to complete this square by realizing what is the middle term divided by 2 squared is. So negative 4 divided by 2 is negative 2. And when you square that, it's a positive 4. So I'm going to add 4 on both sides. I want to be able to write this trinomial as a binomial squared. So I've got to figure out what's going to be inside parentheses. What multiplies to 4 adds and gives you negative 4. Negative 2. So I'm going to have in parentheses x minus 2 all squared. And you simplify the right side. Notice when I take the square root on both sides, this should not just be a 3. It's plus or minus 3, but you're taking the square root of a negative. So I have to represent that negative with an I. So on this, we do get x minus 2 equals plus or minus 3i. And last step is to get x by itself. Move it to the other side by addition. X equals 2 plus or minus 3i. So what if we have 4x squared plus 24x minus 8 equals 0? Constant going to the other side first. Ooh, I switched it up. My bad, I forgot. Actually, in this one, my steps go dividing by 4 first and then moving the constant. Whoops. All right. So I divide everything by that leading coefficient. Then I'm going to move my constant. Either way, we should end up with x squared plus 6x on one side and 2 on the other. Take this, divide it by 2, and then square it. 6 divided by 2 is 3, and then square that. We're adding 9 to both sides. We rewrite this trinomial to be a binomial squared. And then I have to figure out what's going to be in parentheses. What multiplies to 9, adds and gives you 6. 3 and 3. So inside parentheses, x plus 3, quantity squared. And you simplify the left. Or sorry, simplify the right. So in the next step, we've got something squared equal to 11. We're going to take the square root of both sides and be sure we include plus or minus with that root of 11. And then last step is to get that 3 to the other side. Subtract 3 on both sides. New example, let's go. So, divide by 3. Add 3 on both sides. Get rid of that constant. You've got to ask yourself, this middle term, divide it by 2 and then square it. So 4 divided by 2 is 2, and then square that. We're adding 4 on both sides. You've just got to figure out what's in parentheses when you have that binomial squared. I can take that middle term and divide it by 2, or figure out what multiplies to 4, adds to 4. X plus 2 quantity squared equals 7. Take the square root on both sides. Be sure you include the plus or minus. And then your last step is to get that x by itself by subtracting 2. Something that we're going to get to in section 5.8 is where completing the square actually ties into graphing parabolas. We're going to write this function in vertex form following those steps. First step you already saw where I got rid of this constant, which the same thing happens. You get rid of the constant and move it over here. You're just going to be dealing with a y at the same time. Try to think of how you would complete this square. You take your linear term, divide it by 2, and square it. And you add that to both sides. So think, 8 divided by 2 is 4, squared, you probably already wrote it down. I'm going to add 16 on both sides. And then I'm going to simplify one side and rewrite another side to be a binomial squared. So this left side becomes y plus 14 and this right side turns into something squared. And it's going to be that middle term divided by 2. I'm going to have a plus 4. The thing that's different than what we did before is we just have a y here. We're not solving, we're writing the function in a form, in vertex form. So the last step would be, wait a second, what's my k? What's in the k position? And you subtract 14 on both sides. So now I have an equation that was in standard form where I'd have to use the standard form formula to figure out the vertex. When now, wait a second, I can easily see what my vertex is. It's going to be the opposite of this, comma, negative 14. I know my vertex is going to be negative 4, negative 14. No formula necessary. All I have to remember is opposite of that x coordinate.